For everybody. Hopefully you guys can see my screen here. I'm sharing the post that we have today that's out on the forums, and Clint threw it up in the chat so you can follow along if you'd like. As always, our product statement up here. We're going to make forward-looking statements. That's inevitable. That's what we do. So don't make any purchasing decisions based on anything we say. IntelliJ, if you're using IntelliJ, the plugin was updated since our last call. It's currently at 3.86.0, so make sure you keep that updated if you are using IntelliJ. Um, you know, do we have any of our DevRel folks here today? Let me look here. Not seeing anybody. Okay, no worries. So I guess I will quickly go over DPUC sessions. So if you're not familiar, the developer program update call happens once a month, and they recently switched over to using a webinar, which is a little different from the previous Zoom that they were using. So I encourage everyone who wants to attend, and you should attend because it's a great way to get information about what's new and what's coming. You're going to need to go, I'll throw this in the chat, register, and that will allow you to get the link in your calendar and attend those calls.
And Chris Todd's on.
Oh, Todd is here. Excellent. Todd, I forgot you guys are all the different engineering now, which is I'm really excited about. So, office hours with Tony. Again, this is a great way to kind of learn and interact. So Tony's doing these live streams every morning, Monday through Friday, 8 a.m. Pacific. Check them out. It's like a lot of fun. I haven't been able to attend any. It's a little early for me, but I encourage people to check it out. I think Tony's doing a lot of stuff around yeah, agents and um, agentic coding, which is cool. So it might be worth taking a look. Todd, anything else from the DevRel side that you wanted to maybe mention?
Thanks for giving me the chance here. Next Tuesday, we're going to start deep dive sessions. So it should be posted on the forum next Tuesday at, I think it's this time or an hour earlier. But yeah, we're going to be kicking off our deep dive sessions next week.
Awesome. I did see that post and I totally forgot to include it. So I'm glad you mentioned that.
Yeah, it's this time next week.
Cool.
And I see Nick's on as well, so I've just made it possible for him to unmute if he wanted to throw anything else in.
Nick, we covered the DPUC, the office hours with Tony, and Todd just noted the new deep dives starting next week. Anything else you might want to mention? Is maybe he's fighting his coffee. Link for the deep dive. Yeah, let me look real quick.
I'll grab it. I'll post it in the
Okay.
chat.
Excellent. Thanks, Todd. All right. If Nick decides he has anything, he can jump in at any time. I'm gonna keep going here. Okay, some product updates. So one of the product updates that you may not have seen, this just came I think Friday. This post went live. So there's a change coming for WQL for numeric and Boolean values when they're empty. Previously, they would have been represented as null, or the keys wouldn't have shown up. But now they're going to default values in. So for numerics, it's going to actually return with a 0. And for Booleans, you're going to get a false value on the response. So they have an example here in the post. You can see. I'm interested here. This is a string value, not numeric. So I'm kind of curious to see how that's going to look. Now it is worth noting that this is planned for 26R1, and it's in preview now. Okay, so I would encourage folks to go and take a look, test your apps in preview, and just make sure there's no unexpected behavior based on how you're handling things that come back that way. Null today and getting, the 0 value or the false value. This is especially curious here because as a string, this might be treated differently than a falsy value as a numeric. So again, just you might be doing an empty check and it might not work how you think it's supposed to. So just make sure you go and check that out. I'm going to throw this in the chat here. All right. Next up, SAML assertion custom attributes. So SAML assertions, if you're using SSO with the dev site, sometimes the organization, the identity provider that you're using for the single sign-on may require or allow custom attributes to be sent over in the assertion when it goes from one system to the next. So now you're going to be able to set those attributes up in for the dev site for that SSO. Okay. Check out this post from Kevin if you need more details on how to use it. It looks pretty straightforward for setup. All right, Clint got the link. Excellent. And one other thing we want to cover on the product. This is a tip that came across from Joe O'Carroll. It's a PM on the Orchestrate side, noting that there's actually a header that gets returned when you kick off an orchestration that has the ID. And you can use this ID along with the new Insights API to get status on the orchestration, which is really cool. So I put together a little sample app this morning to show how this works. I will note that the way this is named in this comment from Joe, it actually comes across a little different. So I'll show you that. But it's kind of neat because now you could kick off an asynchronous orchestration from a page, and then you can query status on that asynchronous directly without having to store anything in like a model object where you kind of historically how it's handled for that monitoring, doing any kind of lookups. Before I show you the actual page in action, I'll just show real quick the page I built. So I've got my first endpoint here at the top, deferred endpoint that just calls an asynchronous orchestration that I call async test. And it's, let me make this a little bigger just so people can see that. It's a really simple async that just logs, doesn't do anything else. Didn't really need to. Okay, then I've got this other deferred called get work status. Okay, and this is going to use the Insights API for this application for that specific orchestration that I'm calling here. And it's going to pass in the run ID, and it's going to give me overall status information about that run. And then I have another one to get step status information. Now this is this is interesting. I discovered this morning as I was looking at the APIs. There's actually a really subtle difference here. Notice that I'm calling the runs endpoint for both of these, but in one of them I'm passing a query parameter called run ID with the run ID value, and the other one I'm using it as a route parameter with the run ID. And these give different information. So I stumbled upon this because I was looking at the first response I was getting, which I was originally using the route parameter, and I wasn't getting the status, and I thought that was odd. So, and this may have been covered in the Orc KSS. I'm not sure what Mark covered there, but this is something that I noticed and I thought the difference was interesting. Okay, so in the page, we're going to have the invocation of the orchestration, and then I'm just going to grab this response header. Now, it's actually, and I'll show you in the raw response. There's no dashes, all lowercase. X orchestrate ID is how you're going to reference it. That's what the key is going to be named. And it's going to be a list. So we're just going to grab the first one. And I'm storing that in page variables so that I can use it later. And then down here, I'm just calling the two different endpoints, giving them that orc ID, and then showing the raw response. So let's take a look at the actual page here. And I'll put this code up after the session. Okay, so I'm going to trigger my orchestration, and we're going to see the raw response. So we have this key response headers, and it has a map for its value. And within the map, right here, is the X orchestrate ID. And it's got a list. We're just going to grab that first one, of course, right? And this is what's stored in my page variable. So now if I go down here and say update status, it's going to use that ID, call the insights APIs. And this is both calls that are happening. You see the first one with the query parameter and the second one with the route parameter. So the query parameter, we can see we have a data section back, and we have, let's see, where is it? Status code is not what I wanted. I'm totally missing the thing I was looking for. There it is. Sorry. The state success tells us the overall state of that run, right? That's what we want to look for. But the other way we can do it with the route parameter will tell us other information that's kind of interesting. The steps that are successful and the steps that failed. So this gives me like step level, and it's very high level, right? It just gives me an overall number. So I don't necessarily know which, but it's a different breakdown. And the second way we do it, it doesn't give me this overall state. So pay attention to that if you're building something and you want to be able to get information. You may want to use both. Or, maybe you're just interested in this overall state. In any case, it's kind of a subtle difference, but again, the first one's using a route parameter, and the second one is using part of the actual route itself. All right. All right, that's all I had for product news and updates. I'm going to stop sharing and I'm going to kick it over to Clint, and he's going to talk about page performance optimization.
Get that chat up. Well, we're going to tag team on this one just because who wants to listen to me talk for the next 30, 40 minutes? So we're going to talk about some page performance optimization. Basically, we don't want our users waiting. Users, when they're using Extend apps, they lose interest real fast, especially if they have to do those really long waits. So we got to beat that worldwide wait. Of course, only some of us are old enough to remember the jokes about that for www. 100% that on that one, Arnav, is collection will get you every time. Now, when Chris and I were talking this one through, we were talking about the different things that you need to understand in order to be able to properly optimize a page. And one of the big things is page load order. What actually happens and in what order? And how can you tell the subtlety that go along with how do these things come together? How do I know which part of it's actually causing me the trouble? Then we're going to talk about inbound data performance because honestly, inbound data is probably what's causing your problem. Better than even odds that it's your inbound data that's the trouble. We're then going to play around a little bit more with onloads and scripting because onloads can absolutely cause you some trouble. We're going to refer you to a few other KSSs and such that have done some pretty cool things here. And then last, we're going to finish off with some page widget performance. But first off, and like Chris always thought he was going to be able to not talk, but where'd be the fun in that? Let's talk about page load order. Take it away.
Yeah, so first we're gonna have our inbound endpoints that are gonna load right when you load the page. And one of the things here too, you may have wondered about is the ability to use custom error pages. You can only do it with inbounds and outbounds, and that's because this is where the routing is happening, right? These things are being invoked as part of the page load, and so those redirects can happen as opposed to say like a deferred endpoint, right? You can't have a deferred that happens and have that route to a custom error page. This is like Clint said, this is where a lot of those page slowness are going to happen. And it's the first thing that happens in your page. Okay, from there it's onload. And onload is another big one in terms of page performance. You're oftentimes going to be looking at the data that you've gotten in your inputs, right? Those inbounds that are run. And this is where you're going to have to do some sort of processing on it. Okay, and this is where we can get ourselves in trouble as well. From there, our widgets are loaded, and that's where we start the actual page rendering. Okay. User activities, this is where we're actually interacting with the page, right? Filling out data, selecting drop downs, etc. Okay. Now, at this point, users finished interacting, they're clicking OK, they're submitting the page. On submit event happens. If we have an on submit event handler in place, that's where we do some processing. Probably one of the least likely places where we're going to have this kind of issue, but certainly it's possible to have it happen anywhere, right? And finally, the outbound endpoints are triggered at the end as your page is essentially exiting, right? And that's where, again, if you're running any errors, custom error pages can come into play, but there's a lot of processing that can happen here, both in the endpoints being executed as well as any processing happening in your own sense. All right. What do we got
I've
next?
got a private question, which is what's an onload? Great question.
Great question.
Let me just do a quick close on this and an onload is a scripting block that happens in between your endpoints completing and your page starting. So this little constant, which I'll talk about a little bit later on, actually runs in between when the data has been collected and when the page starts to render. That answer your question? Go ahead, Chris.
As I say, one thing I like to think about is the page loads are it's a series of events that are happening, right? And when I write an onload in my code, what I'm really doing is creating an onload event handler. And this handler says, when that onload happens, here's some things I would like you to execute, right? So we have the ability in Extend to have a bunch of different types of handlers, including on load, on submit, and on change, which is another one you're going to see, I think, most frequently between those.
Awesome. Any other questions on how things actually load before we dive into what data performance looks like? So let's not bury the lead here. Great question there, Mo. Does page size affect performance once loaded? And the answer is sort of. So what's going to happen is if you have a really big page, like you've got that page that's full, like, I've got a sample here that's about 65K. And what'll happen is it loads real fast once it gets there, but it takes extra time to get to that page. So we can jump ahead here. It's a great question. Let's go take a look at a page. So here's a page. And here's what's in it. I've put in an embedded image. Now that embedded image, it's the Dumbbell Nebula for those of you following along at home. What happens here is this loads real fast. The actual time between once the page is loaded and once it's rendered is like functionally zero. It is really, really quick. But what happens is it feels laggy. So what I want you to do is I want you to watch what happens here when I click to another page. So I click to this page. Notice this moved instantly. Now watch what happens when I click back. 1, 2, 3, 4, 5, 6, 7, 8. So this is what page size performance looks like. When you have these really big pages, when there's that 100K limit, this is why there's that 100K limit. It gets really laggy as it has to load all that stuff up, build the mediation context. As you notice, there's nothing else here but the image. There's nothing but that image here, but just the sheer size of the text file makes your app feel laggy. So that answer your question there, Mo? That the answer is yes and no. It's going to make your app feel laggy, but it's not actually the image processing or the page rendering that's causing the problem. It's getting that page into the page processor that's causing the trouble.
All right, we got a question also here from Jeremy. Are there restrictions on what can be called in onload? For example, can scripts be called? Yes, scripts can absolutely be called, and actually that's going to be a good way to keep your code clean if your onload gets too big. It can be hard to maintain if it gets kind of too cumbersome. You can really at the point where you're in the onload, the only thing you're not going to be able to do is reference widgets because the widgets haven't rendered yet, so they're not going to be accessible. But you can access any endpoints that have been called, and so therefore your data sources are available. Follow up to that, if you break up your page with script files and pods, does it shorten the page processor time?
So just before I dive into that, Jeremy, so here's an onload, and as you can see, I can call, I've got a script here. I can call that script here, no problem, works just fine. What I can't do is I can't call a value in a page or any of the values in the widgets. So if I tried that, it's not going to work.
Yeah. If you break up your page with scripts and pods, does it shorten the page processor time? I'm going to say no.
No.
I think especially with pods, you're actually adding a little bit of complexity there potentially. I don't know that that's going to necessarily increase time, but it's certainly not going to shorten the load times for you. You can think about it as almost just kind of a lift and shift of, moving things around, but the actual loading that has to happen is going to be the same. Let's see. Base64 encoded images should be faster than endpoint-based images, right? As we get down the time to retrieve the image.
Unfortunately, no, because, and let me just skip ahead on this one. What's going to happen is your images will generally lazy load. So images, your charts, but a lot of those things that you'd think would probably slow you down, attachments, attachment thumbnails, all that stuff lazy loads. So your page is going to come up fast, and then you'll see the images start to load in. This is a pretty common thing. If you just do a quick pull in of worker photos into like a grid or something, or a file attachment loader, you'll see it happen. If you pull in all workers in your GMS tenant, you'll see the grid will render, and then the images will come in as they work their way through. So would an embedded item be faster? No. No, it'll actually be slower. Is it a ton slower? No, but it is noticeable.
So Ethan had an interesting question, and I don't know the answer, but I have some guesses based on some things I know. Do comments play into page load speed by increasing overall script size? Now, generally, programming languages, when things are compiled, um, uh, they strip out comments, right? So when the things are tokenized, comments are just ignored, as the actual processing code is, created. And I imagine it's the same with P&D page as it's being loaded in. Those comments probably don't exist in the actual page that's being rendered. But I can't say for certain because I don't know how that's implemented on the back end. But educated guess, I'm gonna say no.
And I'm going to throw in an extra comment there, which is do not, not comment your code for performance reasons.
Yeah,
Always comment, please.
1000%. Yeah. Yeah, Arnav, even interpreters still have to go through there's still an interpreter, right, that's translating. And also if you think about it, when you build your app, right, it does go through a sort of compilation process too, right? So there's transformations that are happening from when you write that code to it being loaded. And all the other thing to note is comments aren't strictly valid in JSON. I had some fun with this actually when I was writing Arcane Auditor because I had to be able to parse these PMD pages and also deal with processing PMD script. So some of the things I'm saying come from my experience having worked with that.
And to the question about the build is for model components and not PMD user scripts, not true because the build significantly predates model components. Of course, that means I now need to shake my cane and shout at clouds because I'm old. But yeah, the build actually is quite before model components existed. Awesome questions, folks.
Did we
Keep
get
coming.
did we get everything? Oh, Jim asked about an example of an inbound Excel file to custom object. And when you say custom object, I'm assuming you mean a model object and not like a Workday proper custom object. Um, that's a great question. I don't know if we have an example.
Uh, so
What do you,
define what you mean there. Are you talking about an EIB? Do you just need to do a straight Excel load? Because EIB to a model object is supported and pretty easy to do. And I believe we
mm,
did a KSS on that. Did we not?
yeah, we did. Yep.
One
That's a
moment,
good call.
please. EIB for model objects. Should be a sample right here. Awesome.
Yeah, great.
There's lots more stuff you can do with that, but that's a really great place to start. If I'm trying to just do a bulk load into a model object, that's totally the way I would do it.
Right.
You can do some really cool stuff with orchestrations, and Marek's got a very cool uh, orchestration around Excel. But wow, it's not for the faint of heart.
Hmm. Cool. I think we covered everything.
Awesome, sounds great. So data is usually your problem. We've covered a lot of topics on this. I'll show you a couple on the next slide, but the question that we keep coming across is how can I show my user this huge pile of data? And I'm going to keep banging the old drum about push back on usability grounds. Showing a user, even if you can get 1,000 rows to render, and yes, you can sometimes, um, the 1,000 rows in a grid is just not very useful for your users. You need to trim that down. Nobody can keep 1,000 rows of anything in their head. Believe me, I've tried. Um, you're going to find that just to go and read through it, they don't have time. Remember, we're dealing with 24-second timeouts here. If they were to go and change 100 of these items, they may well hit that timeout. And nobody wants to wade through 1,000 rows of items, make 100 changes, and then have it time out. They will, there's pitchforks and torches and kill the monster in the castle sort of responses. And yes, Srinivas, exactly right. If they need 1,000 rows, kick them over to the reporting tool. It's what it's there for. And let me just jump down one little item here. And so Henry, what are your options here? Look at batch protocol. So there's a KSS on this. So the batch protocol allows you to, let me just throw this into chat, allows you to batch together a bunch of REST API calls. So there's a lot of things that can do. There's some limitations. Check out the KSS on this. What it's going to do is it's going to allow you to take a bunch of calls, put them together, and then submit them. And it is way, way faster. Like we're talking like faster in the bulk transaction sort of faster space, only it's bigger than bulk transactions, which are limited to like 100. So this is huge. This is going to be a major game changer for you. And we're seeing it picked up a few places. It's still definitely underutilized. It is awesome. Definitely check it out. Now, one of the challenges that comes up with it is it requires a post. So the post transaction has to be sent there. What you need to do with that is you'll find that pages can be a little tricky to get into a post section so that your endpoints can have a post command HTTP method. What you can do is in this KSS, look for the get post switcheroo. You can just use an orchestration. The orchestration accepts a get, but then presents a post to the batch endpoints. So this is a really cool way, and we've been using this very successfully, putting things together on it.
And yes, for Catherine's question, batch protocol with WQL, absolutely.
Yeah, very cool and very handy. Yeah, the WQL batch protocol. Awesome. Now, there's another challenge that can come up with data, and I'm going to tell you a story because, well, I've changed the names to protect the innocent here, but I had an interesting problem where I was asked to help out with a page that was timing out, and there was an endpoint that was timing out. And this endpoint was always the one that timed out. 100% every time this endpoint timed out. And we took that endpoint out, we put it into Postman, and the endpoint ran in like 2.5 seconds. And there was like 5 or 6 other endpoints here. And we were trying to figure out, okay, why is this endpoint always the one that times out? Because all the rest of the endpoints all ran in a couple or 3 seconds. Like, an interesting thing happens with Workday endpoints. Specifically, they will generally work in parallel. So if I had a bunch of different WQL queries, I submit them all, they will generally go out in parallel. The page processor optimizes this quite well. And what we'd see is all of these WQL statements in my sample code run in about 300 milliseconds. Let's go take a quick look at that app. And if I go to data parallel and I pop this open, let's see how long this takes to load. 1, 2, 3, 4, 5. Oh no, this is taking too long. Why is this happening? Because there's almost no data showing up here. And I'd gotten called in, and I'm looking at this the little tiny endpoint. There's like it's a straight WQL query, and what's going on with this is, well, it's looking for a value. Oh, as soon as you start looking for values, you start passing in parameters. This is passing in a parameter from the previous endpoint. And then this one's looking for a value from the previous endpoint. And the previous endpoint, and the previous endpoint, and the previous endpoint. So what's happened is all of these endpoints are being executed sequentially. So I'm standing up get patina, and then I'm running get sub work. And I can't run get address until I run get sub work. So each one of these is happening one at a time. If you take this out and just use straight get patina off all of them, this page loads in about 1.5 seconds as opposed to 8 seconds. So watch out for this one because it's not often they're quite as obvious as I've set this up here, because the one I was looking at, this wasn't quite so obvious. However, watch out when you're staring at this one endpoint. It's like, why is this one timing out? It's a 2-second endpoint. Well, it's a 2-second endpoint at the end of a 23-second trail of endpoints. Let's see here, Arnav. So I've used where I'm using WQL plus batch to look up workers using email IDs with the work from email data source. Awesome, awesome. I have to work with 30 email addresses. It could be a challenge. Even with batch protocol, it takes 14, 15 seconds. Any options to speed this up?
And I think this is a problem where the API call itself is probably fine, but like WQL processing on the back end, you still have to deal with the whatever latency, right, from those data source lookups.
Yeah. So
So
that
it might
that could
be
definitely be challenging.
WQL optimization more so than anything around the batch.
So other things you can do in those cases, if you are in a situation where you can fob that out to an async and then loop them into a flow, that would probably give you the extra time that you'd need. Oh, no filters in WQL, just the straight email parameter. Interesting. And of course, Henry's option there, I'm guessing that he's going to recommend a join loop, which is about what I'm about to do. Yep, yep. So a join loop there might actually work better for you if you can pull out the data separately and then join loop them together when you're going to present. That may actually be a good way to go, depending on how large your data volumes are. But with 20 or 30 emails, if you can keep that down relatively small, that might actually be a very effective solution as well. Thanks, Henry. Good call. Mo, so 2 questions. Would splitting up the endpoint calls between different pages and setting it by flow variables a good idea? Sometimes, yes, absolutely. That can make for the cases where you've got really long-running API calls, not making the user wait for them all at once. Waiting for 10 seconds as a user is way worse than waiting for 5 seconds twice. If you've got something to break up the boredom in between, that's really going to help out a lot. So yes, putting things into a flow and then passing them through in flow variables or passing them through on a state model object might be a really good way to go here. Is there a way to parallelize the endpoints so they don't rely on each other? In this case, yes, absolutely. This is a mistake. This is absolutely an anti-pattern, hence the name anti-pattern do not use. If we were to take all of this, because they're all picking up the same WID, could I just split them all up into this? Yep. It'll still be slightly serialized because the first one has to run, but after the first one runs, then the rest of them are all using the same one. So all the rest, the other 6 or 7 here, can become parallel. So can we parallelize the endpoints so they don't rely on each other? In most cases, yes, you can, and that's what I will absolutely recommend. Split your endpoints out so they don't rely on each other, put them together with batch protocol. There's lots of cool things that you can do here and lots of good choices that will give you really good bang for your buck. That answer your question there, Mo? And to the anonymous attendee, if I have additional endpoints on the page which are not being referenced anywhere on the page, is it going to load them and is it going to affect performance? Yes. You'll even get a warning on that one. So if I hit validate on this, you'll notice that I'm getting a warning here. It's declared but never used. That's why it's there. That's telling you, hey, this is not being used. Why are you making me load this thing? Now, it's a warning, not an error, because it doesn't always know what you're doing. So sometimes I've loaded up endpoints that I'm using in scripting or other things that maybe it's not obvious to my processor. Yeah, I'm actually using that. But this is a warning, and yes, it absolutely does cause slowdowns because you'll notice that I only loaded 2 values on this page, but it had to go through all the rest of that stuff. So it had to slog through all these pieces before it came back to that page. So yes, big yes. If you don't need that endpoint, don't run it. Just flip it to a deferred or take it out entirely. Arnav, inbound endpoints would still be sequential even when not depending on each other, right? No, they will run in parallel.
Yeah.
So what's happening here is now Get Patina is going to run. And we'll see this should load in about 2 seconds, 2.5. You can see how much faster that was because what happens is it runs Get Patina and then all the rest of these run in parallel. So inbound endpoints do run in parallel as much as they possibly can. So this is kind of one of those huge things that it feels, because you're declaring them in order, you'd think they execute in order. No, they actually execute in parallel. It figures out what order it does. It's a pretty smart little processor on it that figures out how fast it can put these things together. And yeah, Jeremy, exactly right. If it's used in a pod, it absolutely will not know if it's being used, because it doesn't see it on the page. And yes, Renavas, 100%. Whenever you're looking at page performance, number one thing to look at is endpoints. If you are looking at the WQL endpoints, data sources that you're looking for, these things can be really, really slow, fast, or whatever. We did a whole WQL optimization session in September in the Wizard session, so definitely check that one out. Choosing the right data source is going to hugely affect your page load times. Let's move over to onload and scripting. Chris, you want to take it away?
Yeah, so for when we're talking about the onload event handling and scripting, we're not necessarily thinking in terms of page speed. Now we're kind of switching our focus to our memory allocation, right? And how much we're allowed to use. And what you're going to see most commonly is when your data sets are big and you start trying to do that processing and onload, is you're going to run out of memory because there is a cap, right? That you're restricted to in how much memory. Now, what that cap is not advertised, and being able to measure is kind of hard. So we did a KSS on this. It was February of last year. It was the last KSS call we did, where we talk about optimization for this. But most commonly, what you're going to see is when you have array methods like a map or a for each, and inside that map or for each, you have, say, a filter or another map or another for each. And when you have those nested, you're exponentially growing the number of iterations that have to happen, and your data is going to grow as well, right? So you have to optimize that, and there's a strategy that you can use to do that, to basically extract out that inner map, that inner loop, because it could be a for loop as well, right? It doesn't necessarily have to be those array methods. But really the key there is you can utilize, you can build a map and then you can access those. I would recommend checking out the KSS call on this though, because we go in depth on how to approach this problem. But those nested array functions can really get you in trouble. And I will say every time I've ever seen anyone posting on the forums about having an issue with their page running out of memory, that's immediately what I scan for in their code is those nested loops. And 100% of the time, that's what we find, and that's how we can address it. Also, shameless plug. Arcane Auditor has a rule in it where it will detect in your code if you have these embedded or nested array functions. And if you have a page where you're running out of memory, and Arcane Auditor says, "Hey, this is potentially a problem," you can two and two together there, and maybe that's where you start with your optimization. Let's see. Using embedded script in the PMD, does it affect any way in performance? How do you mean? Do you mean like an external script file? Because it certainly will impact page load times if you're doing any kind of scripting in your onload, right? And remember, we have a 60-second window here for those endpoints to run and your onload scripting to happen as well. External script file. Yeah, so it's not going to affect your performance any more than having those scripts directly on the page would. But the scripting itself in either case can affect the performance on your page. At what point would poorly written code affect the performance of the entire tenant? That's a good question. I will say there's one thing that can very easily do that, and that's using something like an is collection on those inbound endpoints, which I don't think we talked about too much, but I know Arnav commented about his collection early in the call today. I don't think you're going to have generally your scripting performance affecting it, but you certainly could. And the case where it's going to happen is when you have a high number of users who are using the application at the same time who are utilizing that page. But again, generally speaking, it's your inbound endpoints that are going to get you in trouble there. I don't think your scripting is less likely. And a lot of that is just because of some of the gates that they have in place to the memory limits and processing caps on time around PMD script execution.
The other one that we've seen take tenants down is when people try to put in dummy loops for ersatz waits. So where they're trying to make their code wait for a few seconds because of a slow external call or something like that. Those dummy loops have caused problems with tenants. We've seen it take tenants down.
I think Orchestrate is kind of the most likely place you're going to have that, right, Glenn?
Yeah. Yeah. But 100% agree. If you start, saturating your object reporting services, yeah, that's when you start seeing tenants go down.
Based on an endpoint response value, can I use onload to hide a few fields' visibility on the page?
The answer is no. So the onload can't do that because the page hasn't rendered yet. So onload is between the data servicing and the page actually rendering.
Yeah.
So if
you could use a page variable and load that page variable up in your onload. So basically you would have a widget, a visibility tag, and in that you would use a check against the page variable. And then in your onload, you would populate that page variable. And that would be one approach you could use. I don't know if I love it, but I think that would work.
That would work, but I would say just set the visible value here based on whatever data you are pulling out from your outbound or your inbound endpoints. So totally would work, but probably more complicated than you need. And yes, Arnav, that is one way to achieve a sleep, a very big sleep.
Yeah, that's right. Let's see. For PMD page that is created but not used by the application, will that cause performance issue? For example, I have a page that acts as a backup page to another page before I make any changes. This allows me to quickly reverse the change by just copying. No, having the page in your application that's not being utilized isn't going to affect your performance. That's true, specifically because pages don't directly reference other pages. There's no cross dependencies there, so it'll be part of the package, but it wouldn't be invoked in any way. Does the number of page variables used affect performance?
I'm going to go out on a limb and say yes. To some extent, it depends on volumes.
Yeah, and it's a single it's like a single variable. So you can think of page variables as like a map that you can add keys to, right?
Yep.
Um, and you could certainly add enough data in that to like blow your memory limits on the page. It would be hard to do. Don't take that as a challenge.
But what I've often seen people do, referencing the earlier questions about flow variables, is where people are putting stuff into flow variables. Page variables are also in the mediation context, and you throw a ton of data into a flow variable and then try to move to the next page. It's got to pull all that data with you. So you want to make those transitions as light as possible because that's going to really slow things down.
All right, Mel.
And yet, both Srinivas and Afton, 100% retry is definitely something we're all looking for. You can sort of get to it with HTTP retries in Orchestrate, but there's still a lot of limits there that we have to hit.
Yeah. All right, Clint, we got 7 minutes. What else we
7 minutes. Last thing, let's talk page widget performance. So, actual use of an onload, creating a page variable. So, how if you can't measure it, you can't manage it, right? So we can time how long it takes to load a page because unlike endpoints, widgets load sequentially. They load from the top to the bottom. So what you do is in your onload, you throw a start time page variable in, and then on your last widget, do a date now with a between. Easy peasy. It will tell you how long it takes your page to load. And when is this going to hurt you? This is going to hurt you on grids. Grids are going to be, if someone says, "Hey, my page won't load," I generally ask, "Well, how many grids have you got, and how big are they?" Because they are, Jeremy. This code will be available on the GitHub, so you'll notice that I'm using that right here. So you can just steal it straight out of the code. Don't even need to make a screenshot of it. And the deck's available as well.
Yeah, we'll get that posted today after the call.
Yeah. And you notice I'm just in the onload, set that up, and then see how long this takes to run. Now, grids are usually the trouble here. Now I've got a pretty straightforward grid. It's loading up 200 rows. What takes the time? There's two things that are going to slow this thing down. The biggest thing is when you're dealing with data. So instance lists on grids are painful. Why? Because I'm loading up a ton of information here. Just for Arnav, I threw in an is collection just to really make it hurt. So when I try to load this up, and I'm going to talk for a while over this because, oh, sure, I'm going to go connect again. This is going to take 10 or 11 seconds to load. All workers here, even with the is collection, takes less than a second. Just the page processing here is going to take 10, 11 seconds. And all it is some grids, or a grid with 4 columns with instance lists on it and 1 with a number. Notice that it's still going. That took 10,000 milliseconds to load. And this is one of those things where people always come back and say, "What am I supposed to do?" I mean, the answer here is go to a view grid where you're not loading up those instance lists, you're just showing the data. If I do that, this is going to present a grid that looks the same. It's going to look the same. It's not editable. And it loads in 600 milliseconds. 10,000 to 600. It's that much faster to go to that view grid with individual edits, design pattern that we keep talking about. That's why we do, because you're talking 2 orders of magnitude faster to load up the same data to the user's experience. So this is a huge step forward that you can really take and go a long way with. And to one of those earlier questions, does PMD scripting affect page load performance. If you look at the formatting element here, I was just playing around. It loads up 1,000. I'm just doing a square root of time here, and that takes about 15 milliseconds. So you can see PMD scripting is pretty fast. That's a fair number of operations to be doing, and you can just start playing around with it. Try it out. See what sort of things you can do, and start playing around with the timing. So if you've got something you're thinking, maybe that PMD scripting is causing my problem, create a little page like I've got here. It allows you to do an iteration on it, put in whatever scripting you're looking for to see what it's actually doing, and see how long it takes. This is going to be one of those great little tools that allows you to say, hey, is my page rendering the problem, or is my data servicing the problem? And that's going to be hugely valuable for you. And to Arnav's question, considerations for putting an endpoint data in flow variables versus running the endpoint again in the next page. Data volume. How big is it? If it's really big, you're better to rerun it, because you're using a data servicing tool, a REST API, WQL, Graph, whatever, to go get that data. Typically, what I find myself doing with flow variables is I'll take whatever key values I need to make that rerun fast and effective. If you're dealing with a lot of data and wherever you're getting it from is really slow, it's an external data source or something, build a state variable, build a model object that you can store that information in with a precise key that allows you to say, hey, I'm in this flow, state I'm looking at, go grab it out of there. You'll find that's very quick.
Yeah. And
Caching's always, go ahead.
sorry, I just wanted to say another small benefit is cognitive load. Like if I'm calling it on the page, I'm using it. It's just like less for me to have to think about.
Yep. I don't have to jump back to a previous page to think, what's in this data? And we already talked about images and charts. I don't think I actually showed the charts. So this is loading up 20 charts of some pretty significant data, and you'll notice that they lazy load. Like the page comes back real quick, and if I just scroll off, you can see it lazy loading for me. So don't be afraid to use charts. And that brings us to the top of the hour.